Hello everyone, I am Ashita Thampi from TKM College of Engineering. I am here to explain some of the important equipments that are used in our electronics and communication laboratory.
So I will be explaining to you about the DSO, the function generator and the multimeter.
So now let's begin with the function generator. It is used for generating signals. We can generate sine wave, square wave as well as triangular wave. By pressing on the wave button, you can choose whether you want a sine wave, square wave or a triangular wave. The type of wave that you have chosen will be displayed on the screen. By default, the frequency is set to 1 kHz. You can change the frequency by adjusting the frequency knob, or you can also manually enter the value that you require. You can obtain a maximum frequency of 3 MHz. Now the amplitude of the signal can be viewed by pressing on the shift followed by V button. You can see the amplitude on the screen. By adjusting the amplitude knob, you can vary the amplitude of the signal up to a maximum of 10.96 volt. With the help of the attenuation button, that is by pressing on shift and this minus 40 dB, you get the minimum amplitude, which is 1 volt, 1 millivolt. Now the output can be obtained from the two ports that are present, the TTL as well as the main port. Generally we use the main port, which has an output impedance of 50 ohms. The TTL output port is used for driving the TTL logic family ICs. We also have a duty knob as well as an offset knob. The duty knob is used for adjusting the duty cycle of the square wave, and the offset knob is used for adjusting the DC level of the sine wave. Now we move on to oscilloscopes. Oscilloscope is an instrument that is used to display and analyze the waveform. We have two types of oscilloscope, the cathode ray oscilloscope and the digital storage oscilloscope. This is the digital storage oscilloscope, also known as DSO. It can be used to analyze waveforms up to 50 MHz. Basically, it can be used for various purposes, but now we will be dealing with only some of the basic requirements. First of all, it has two channels, channel 1 and channel 2. It is used for analyzing waveforms simultaneously. Now let us see an example. I am connecting the probe to channel 1. The output waveform is obtained. By pressing on the auto scale button, the DSO will scale the signal automatically. You can adjust the volt per division by turning this knob, and you can adjust the time per division by rotating this knob. By pressing on the channel 1 button, you can view various options. The first, we have coupling option. On pressing on this, you can see DC, AC and ground. You can adjust by using this knob. It is called the push to select knob. You can choose ground. When you choose ground level, you can adjust the ground level by rotating this knob. Then we have AC and DC. The AC coupling is used for viewing the sine wave with the AC components, and the DC coupling is used to view the wave along with the DC values. Now we can measure various characteristics of the waveform by pressing on the measure button. We can measure the various characteristics of the waveform like voltage, time, frequency, etc. By pressing on this button followed by display on, you can obtain all the characteristics of the output waveform. As you can see the Vmax is 5.2, the frequency is 1 kHz and so on. Multimeter is a multi-purpose device which is used to measure voltage, current, resistance, capacitance. In modern days, we can also measure temperature as well as frequency. By rotating this knob, you can choose whether you want to measure voltage, current, frequency or continuity, resistance, etc. We have a 9-volt battery here. Let us check its voltage. First, we have to rotate the knob and set it to 20 volt. Now we have, with the help of the LED, we have to measure the voltage. We can see the voltage is 8.73. So this 9-volt battery will give you a voltage of 8.73 volts only. Now let's measure the resistance of this resistor. First we have to turn the knob and keep it at the maximum resistance range, that is 2000 mega ohms. Now we have to measure the resistance. We have to reduce the range, and now we can see that the resistance is 31.5 kilo ohms, which is approximately 33 kilo ohm resistor. Now let us check if this diode is in good condition or not. First we have to change the knob to the continuity mode. This is the continuity mode of the multimeter. Now by connecting it in forward bias, we can see a 3-digit number, and when we connect it in reverse bias, we can see that there are no values displayed. This means that our diode is in good condition. Now let us check the AC main supply voltage. Now we can see that the voltage displayed is 226. So the AC supply voltage is 226 volt.